morning. So for today, I'll be discussing about the variable separable differential equation. So what is the variable separable differential equation? If all terms containing x can be grouped with dx and all y can be grouped with dy. So if the terms of x can be grouped with dx and all y with dy, the differential equation is said to be a variable separable. So there are two types of solution. First is the general solution and second is particular solution. General solution, a solution that contains a arbitrary constant that is not defined. So in differential equation, when solving the final answer, there is a constant. So if the constant is not defined, it is a general solution. So this the particular solution. A solution that no longer contains arbitrary constant. The constant is defined, meaning that the constant has a value. Our first example for the variable separable differential equation is y prime is equals to 2y over x. Y prime can be written as dy over dx is equals to 2y over x. The variable separable said that all terms of x can be grouped with dx and all terms of y will be grouped with dy. So in order to group them, we need to cross multiply. Dy over 2y is equals to dx over x. So we already have grouped them. And we need to integrate because we finish grouping them. So by integration, there is a 2 constant here. We need to factor out the 2. 1/2 integration of dy over y is equals to integration of dx over x. So integration of dy over y is equals to ln of y. Integration of dx over x is equals to ln of x. Whenever we do integration, we always put a plus constant. So in the properties of logarithm, we need to cancel out this 1/2. We multiply to both sides. So 1/2 multiplied by 2 is cancel out, remaining is ln of y, and is equals to ln of x multiplied by 2 is equals to 2 ln of x, and plus c, and c multiplied by that constant is always a constant. So copy ln of y is equals to 2 ln of x is can be written also as ln of x squared plus c. So we already have the ln value, have the x and y terms. So we need to cancel out this ln sign. In order to cancel out this ln sign, we need to exponentiate both sides. E raised to ln of y is equals to e raised to ln of x squared times a raised to the constant. So cancel out the e and the ln, we have the y remaining, and is equals to cancel out the a and the ln is equals to x squared, and e raised to c is it's also remains constant. So the final answer is y is equals to c x constant x squared, and in this answer the constant is not defined, so that the solution here in the variable separable example number 1, it is a general solution. Another example is dr over dt is equals to negative 4rt. T is equals to 0 and r is equals to r sub 0. So use the r for variable of x and t for the variable of y. So we need to group this r to dr and t to dt. So dr is equals to r and equals to negative 40 dt. So we already group them to r to dr and t to dt. We need to integrate both sides. Integration of dr over r is equals to put the constant outside, negative 4 integration of t dt. So integration of this dr over r is equals to ln of r is equals to integration of negative 4 t dt is equals to negative 2 ln of t squared plus the constant, integration of constant c. So we already have ln in both terms. We need to cancel out ln in both terms. So e raised to ln of r is equals to e raised to negative 2 ln of t squared multiplied by e raised to c. So cancel out the e here and the ln. We have remaining r is equals to, cancel out the ln, we have to e raised to negative 2 t2, and e raised to c is always a constant. So we rewrite this into this c r is equals to e raised to negative 2 t2. This is our final answer? No, because we have a condition that t is equal to 0 and r is equal to sub 0. We will substitute this t equals to 0 and r equals to sub 0 to in this equation. So c multiplied by r, so r is equals to r sub 0 is equals to e raised to negative 2, and the t is equal to 0, put this 0 squared. So we divide both sides by r sub 0 in order to cancel out here. So c is equals to e raised to negative 2, 0 raised to 2 is always a 1, and divide both sides by r sub 0 is equals to c is equals to 1 r sub 0. Then in this one we have the value of the constant. We need to substitute the constant in the general solution. Then c is also 1 over r sub 0 multiplied by r is equals to e raised to negative 2 t2, and to cancel this 1 over r sub 0, we multiply both sides by r by sub 0. So the remaining in the left side is r, and equals to r sub 0 multiplied by e raised to negative 2 t2. So the final answer is r is equals to r sub 0 exponent of negative 2 t2 squared. Here we have already have a value of the constant. So the variable separable differential equation said if we have a value of constant, it is a particular solution. Another example of variable separable differential equation: my dx is equals to nx dy. So the variable m1 in here is, we assume that it is constant because there is a term of x for dx and a term of y for dy. We assume that m1 in that is constant. So we will group this x to dx and y to dy. Divide both sides by x over y, x and y. So in this, we cancel out the y, so m dx over x is equals to, cancel the x in dy over y. So upon finally get the group of x to dx and y to dy, we will integrate both sides. So there is a constant, we will factor out the constant. M integration of dx over x is equals to, factor out the constant in integration of dy over y. So integration of dx over x is equals to m ln of x is equals to integration of dy over y n ln of y, and plus the integration in constant c plus c. M ln of x can be written as ln of x raised to m, and is equals to n ln of y can be written as ln of y raised to n, and copy the plus c. So we have the ln sign of both terms. We need to cancel out the ln sign. We need to exponentiate both sides. So e raised to ln of x raised to m is equals to e raised to ln of y raised to n, and e raised to the constant c. So cancel out the e and the ln. We have the remaining x raised to m is equal to y raised to n multiplied by the c. So in other form, x raised to m is equals to c multiplied by y raised to n. So this is our final answer since the constant has not defined the solution we use is general solution. Another example, x plus 2 dx is equals to x plus 3 sin of y plus of y dy. So we need to eliminate the x plus 3 in the dy term. We'll divide both sides by x plus 3. So x plus 2 is equals to our divided by x plus 3 dx and sin of y cos of y dy. So we'll already have grouped the x term to dx and the y term to dy. We need to integrate both sides. Upon integration of this equation, we cannot integrate this easily. We need to make the numerator the same as the denominator. We can add a constant in the numerator and not the x term, x and y. So x plus 3 minus 1 is equals to x plus 2 divided by x plus 3 dx is equals to integration of sin of y cos of y dy. In this, we cannot integrate this easily too. Let u is equal to sin y and du over dy is equals to cos of y and the du is equals to cos of y dy. So x plus integration of x plus 3 divided by x plus 3 dx minus the minus 1 factor of the dx over x plus 3 is equals to integration of sin y, let the sin y du and the cos y dy as the du. So here cancel out. The remaining is the integration of dx and then we let u is equals to x plus 3 and the du is equals to dx. So it's equals to integration of dx is the du divided by x plus 3 is the u. We will put u is equals to integration of u multiplied by du. So integration of dx is equals to x and integration of du over u is equals to negative ln of u and integration of u multiplied by du is equals to u squared u raised to 2 is equals to divided by 2 plus the constant. So the u variable here is equals to x plus 3 and the u variable here is equals to sin of y. We need to substitute the equivalent of u in the x term and the equivalent of u in the y term. So x minus ln of u or x plus 3 is equals to u squared divided by 2 or sin y squared divided by 2 plus the constant. Since we already have the answer and the constant is not defined, the solution we use is the general solution. Our last example for the variable separable differential equation is x cosine squared of y dx plus tangent of y dy is equals to 0. First, we need to eliminate cosine squared of y in the x term and we divide both sides by cosine squared of y. So x cosine squared y dx divided by cosine squared of y is equals to x dx plus tangent of y dy over cosine squared of y is equals to 0. Then we finish grouping the two terms x and y. We need to integrate both sides. So the integration of x dx is x squared over 2 plus we cannot integrate tangent of y over cosine squared of y. We need to separate them first. So tangent of y multiplied by 1 over cosine squared of y dy. It's also the same as this equation. So 1 over cosine squared of y is equals to secant theta. So factor out the over 2, so 1/2 x squared plus integral of tangent of y secant squared of y dy is equals to 0. So let u the tangent of y. Du with respect to y is secant squared y, and the du is equals to secant squared y dy. So copy that 1/2 x squared plus the integration of tangent of y is u, and secant squared y dy is du equals 0. So that we copy that is the equation here. 1/2 squared is 1/2 x squared plus use the integration of this u du is equals to u squared over 2 and plus the integration constancy is equal to 0. Then we eliminate the 1/2 by multiplying the 2 both sides. 1/2 x squared plus the u is tangent y squared over 2 plus c is equal to 0. 1/2 multiplied by 2 is the remaining is x squared plus tangent y squared divided over 2 multiplied by 2 is cancelled na 2, and the remaining is tangent of y squared. Then the constant multiplied by a constant is always a constant. The answer is x squared plus tangent squared of y plus c is equal to 0. So that our final answer, the constant is not defined, so that the equation here is the general solution.